There's a lot of different performance factors that can cause the system to work well or to not work well. I'm not going to go through all these today. This is something that should be covered by the representative that's looking at your particular problem and specifying the product. There's a lot of things to consider as they go along. But since you already have a system in place, we're going to go through some kind of the top 3 performance factors for your current system. Again, this isn't to try to sell you something new. This is just to show you some things that you could do to your current system that could beef up its performance, hopefully. So the first one is air pressure. There's a relationship between force and time. So you have the air tank and it's filled with air, and we need to release that. We need to open the valve, release that air, and through a discharge, and that's what moves your material. So the relationship of force and time, when that valve is opened, you can see the what we call the peak force, basically the most energy that the cannon is going to create is instantaneous. When you open that valve, you go to a certain amount of peak force, and then the volume in that tank will drop since you open the valve. It's releasing all that air, and the area underneath that triangle is what we call the impulse. That is the energy that is in that tank, the air, and how well it pushes the material. So you need your peak force to have enough to break the cohesion of that material against a wall or against itself, and then a certain amount of volume in the tank to help push that material where you want it to go. So since you can't change your tank, we're going to talk about the relationship of the air pressure when tank volume is the same. Now, you can change your tank, but again, this presentation is about what you can do with your current system. So peak force, as you increase the volume, or as you increase the air pressure, the peak force will increase on a linear scale to that increase in pressure. So if you're running, and actually the volume of the tank doesn't have much effect at all on the force output of the cannon. It has the effect on how the duration of the blast. Again, we aren't going to change the tank. So in order to increase the performance of the air cannon itself, the way to do that, the easiest way to do that is being able to increase your air pressure. So I'll show you a couple examples. At 4 bar, if your cannon can produce 2,500 newtons of force, at 6.9 bar, it's going to produce 3,800 newtons of force. So really, one bar of pressure increase gives you around a 20% increase in force for whichever cannon you're using. It's different cannons have more efficient valves and things, but again, for the one that you have, whoever you're using, if you increase the pressure, you're going to get a nice increase in force output or performance of that cannon. Now, there are a lot of things that affect air pressure. So when you're out, or you send one of your process engineers out to look at your system, first of all, it's the compressor itself, the size of that compressor, whether it can produce the volume that you need and the pressure. So I've seen a lot over the years. Usually the first part of the system goes in and there's plenty of air pressure and plenty of air volume. As companies add more air cannons or add more equipment, that pressure drops. And cannons are a significant investment. The whole system, when you buy nozzles in the cannons, you don't want it to be underperforming because you didn't look at the compressor size. There's always a pressure regulator that regulates each one of the cannons, or each bank of cannons. Make sure someone hasn't set that at 4 bar when it can be run up to 6 bar. The biggest thing, airline leaks. When you're walking through looking at an air cannon system, listen for the air leaks and look for the air leaks. There's that one small air leak can drop that cannon 3 or 4 psi, 5 psi, and then the subsequent cannons down the line. The valve seal itself, there's a there's got to be there's some sort of piston or sealing system inside that valve that will block off the discharge and allow the tank to be filled. If that seal isn't made, then it's just like a large air leak. And when that one cannon is draining, it's taking away from the rest. You have to look at the amount of equipment being used. If your guys go up there and you see you've got a lot lower air pressure than you did the day before, there's usually you know, you can get a hot spot on the somewhere on your tower, and the guys bring one of those air blowers in to keep the skin of the tower cool, and that really drains your system. You know, there can be people working, whatever it may be, but there's the amount of equipment being used takes away from the volume of air and the pressure that can be provided. So those things, and then the next one is the timing of the firings, and I've got that asterisk because it is the next thing that is a performance factor. So the frequency is the cycle of each cannon, like the cycles per hour of each cannon. So you might have if these 4 cannons that you see on the side of this clinker cooler, they might be on a 10-minute cycle, right? So 6 times an hour they're going to fire each cannon. So that's the frequency of the firings. The timing would be the dwell time in between. So if I fired this cannon on the left-hand side, it blasted, and then 2 seconds later we fired the next one and the next one and the next one. That's your timing. That's your dwell time. Now, the problem there is if you have, like this particular application we're looking at, you have a single airline that's supplying all 4 of these cannons, and you blast the first one, and there's a lot of times I see that there's no isolation in between, one-way isolation between each one of these cannons. So what happens is the first cannon fires, and the airline's trying to refill that cannon. Well, it pulls some air out of the other 3 that are next to it. So if you fire this one and it's at 6 bar, the next one might be, if you fire it very quickly, might end up only being at 5.5 bar, and so on. So giving a little bit of time in between, if you blast all these cannons can be on a 10-minute cycle, but leave a minute or so in between them just to or isolate the line, so that you can allow the next cannon to get back up to pressure if it did drop while the airline's trying to fill the one that was released. So just increasing the dwell time in between will help with those situations. Or a lot of times guys will fire way too quickly. It's really depending on the application or the situation, how fast you would want to fire these cannons. But for every minute that you can increase in that frequency, gets you 12 cubic meters per hour of extra air. So it's just so if you have cannons on a 10-minute cycle, increasing them to 11 or 12, as long as it's giving you the same effect, helps the entire system. So the frequency, as I said, should meet the desired need. In a riser duct application, on the kiln inlet, anywhere pretty much on the preheat tower, we average somewhere 10 to 15 minutes. Each one of those cannons fires every 10 to 15 minutes. On the cyclones, it's probably more in the 20-minute range. All depends on how often that buildup happens at the discharge of the cyclone. There's no point in firing every 5 minutes when you don't need to, because it's a huge drain on the system, and it's a waste of compressed air, which is costly. Now you can get into raw material feed chutes. We've got customers firing every 2 minutes. 5 minutes is a pretty good average, but again, you have to it's set to the application. So someone going around looking at the timing of the firings and what can be changed is very beneficial. So increasing that time if you don't need it. So we've talked about air pressure and the frequency and timings of firings, and the biggest thing is nozzles. And so you've spent your money on an air cannon, getting it put in the right place, using the right type of nozzle, and then even the condition of the nozzle as it wears or as the system works are all factors. There are basically two different types that are used in essence. One is a pipe nozzle, which is it can be different materials, obviously, but it's basically a pipe. If we're a 4-inch cannon, you're using a 4-inch pipe, and the pipe nozzle gives you the most performance because there aren't changes in direction. You aren't causing turbulence in that blast. So the most force output you will get will be from a pipe. However, as you can see from these photos, the pipe nozzle has a nice distance to it, but it's a very tight blast. It's not going to expand and clean walls like the fan nozzle, the one on the right-hand side. It's designed, it will reduce the total force output, but it spreads out that blast, because mostly on vertical walls on a preheat tower, you're looking to clean that wall, and you're looking to maximize the amount of cleaning area that you can get out of that cannon. If you use fan nozzles, you can put 2 cannons and 2 fan nozzles, where it would take 3 cannons and 3 pipes to clean that same area. So it reduces the amount of air cannons needed, and it cleans more efficiently. Now, with those fan nozzles, we have all kinds of different nozzles out on the market from our company and others. And again, you want the person who's specifying the application to get a nozzle for the desired need of that application. If you want to shoot down the kiln inlet, you can use 45-degree nozzles. 90-degree and 180-degree opposing nozzles are good for specific applications, different corners. All depends on where your buildup may be. So there are a lot of different nozzles for those for different applications. Now, you aren't going to be able to change a nozzle on the fly here, but if you send someone out to look at your system, they're not going to be able to change nozzles, but you do need to determine what type you're using, whether you are using a fan style nozzle or just pipes. So because then when you do have a shutdown, or you have an opportunity, you could change out that nozzle tip. So the nozzles actually, they create that outcome that you're looking for. You're trying to clean material, you're trying to move it from one place to the next, you're trying to clean it off of a surface. So the nozzle is what creates the outcome that you're looking for. This particular photo here is a spray tower, and the cannons that are mounted to it have 360-degree blast on those nozzles. There was buildup on one side of the conditioning tower, and this is how we solved the issue. But if you think about it, if I only put in pipes as opposed to a 360-degree nozzle, I'd basically blow 4 or 5 holes in the material versus cleaning it off the surface. So again, if the biggest thing when I'm talking to customers about new products or about a new cannon system, nozzles tend to get overlooked a lot of times, and they are more important. Putting them in the right location and the right type of nozzle, they're more important than the air cannon itself. So the thing about the nozzles is follow the installation guidelines, whether it comes from the OEM manufacturer of the tower itself, or you're putting on nozzles during a shutdown or on a new application. You've spent a lot of money, as I said, on the cannon. Just a few degrees off one way or the other with a nozzle, and then you embed it in refractory, you basically wasted that cannon. If you're shooting out into the middle of the tower as opposed to cleaning the wall, that photo on the right-hand side is a nozzle embedded in the wall, and we're cleaning the adjacent wall surface. If I mount that nozzle, half a meter out onto the wall, it's not going to clean the adjacent wall, and you've basically wasted it. Just like same with the angle. If the angle is off and I'm shooting out towards the center, your cannon is pretty much useless. The picture on the left is an FLS crossbar cooler. They design it in with different air cannon nozzles, from fan nozzles to some pipes, depending on what they're doing. But the thing about it is, a lot of times the cannon installation gets pushed off onto the guys that are putting in the refractory. They don't have a whole lot of guidelines. They aren't looking at installation manuals. They don't really care, and it is very, very easy to get a nozzle installed incorrectly, and then basically everyone thinks the cannon isn't working, but if it's not installed correctly. So as your guys go out and look, determine what sort of nozzles you're using, whether they're pipes, whether they're fan nozzles, and where they're located on the system. This is a big one. So once the nozzle's in, don't split the discharge. One cannon per nozzle. If you have as I stated in one of the slides earlier, if you have 2,500 newtons of force and you take that cannon is capable of producing, and I split it into 5 discharges, you've got 5 cannons at 500 newtons of force and very, very little volume. So if you're going to, if you have multiple locations, you're going to look to put on 1 cannon per discharge, or 1 cannon per nozzle. Mounting at a negative angle. This is something that you guys can go out and look at in your current system. The photo on the left is the kiln inlet before picture, where all the cannons were put on basically because that's where they fit. Actually, the drawings probably came from the OEM, and that's where they put them. A, you can't work on them, and B, you're going to have problems with that installation that I'll show you in the next slide. So mounting those cannons up just the floor, just above, and see where the yellow box is. We put cannons in and pipe down. You're in the same locations on the kiln inlet, but the cannons are able to be maintained, and they're at an angle pointing downward. Because what happens there on anything with a negative angle, you're going to end up with the nozzle being burnt off and material falling back into the discharge of the cannon. So as you can see, there's on the little illustration there, there's 90-degree nozzle shooting down a kiln inlet. When that nozzle wears off, there's a hole in it. So if the cannon blasts a few times, it'll blast out into the middle of nowhere, and then material will pour down into that nozzle and fill it up, like this bottom right-hand photo. When that happens, that cannon is useless. Mounting above, at least if that nozzle were to burn off, the material is not going to come down and get into the cannon itself. So that's an easy thing to send guys around and look at, see how your cannons are mounted. If they're mounted at a negative angle like this, it was most likely put in there because it was easy for someone to install it, as opposed to running it into a correct position. The big thing is looking, not listening. Cannons are loud, and there's a couple of different valves usually that have to operate to make the cannon work. And so if you're just listening to it, you're going to hear a pop, and the person who pushed the solenoid or actuated the cannon hears a pop, and they think, oh, that cannon worked. Well, that isn't necessarily the case. If you have buildup in your nozzle, or basically, I guess I should say, if you have no restriction at all, and I'm going to hit this little video, it's a very quick video, but you can see that the air gauge is sitting at 100, almost at 100 PSI, and when it gets to 100, it will fire. The only thing that should slow down that needle is the glycerin that's in the air gauge, because there should be a clear shot with that cannon. Let me see if I can get this to play. I'll play it again because it was it's very rapid. So it is very quick. It goes from 100 to 0 as fast as the needle can travel. If you have a blockage in that nozzle, like that bottom picture, or in your pipe, that nozzle, or the speed in which that needle travels will be a lot slower. It will also be, or it could also, if it was completely plugged, it will go from 100 psi or 6 bar or whatever it may be to down only to 4 bar, because the air tried to blast out of the cannon. It went down a pipe. It met an obstacle, and the air came back into the tank. So just listening to it, nobody can tell, or not very many people can tell, and especially in a loud environment, that the cannon's working. So when your guys are going up and evaluating a system, watch the air gauge. Make sure it discharges very quickly from whatever the set pressure is down to 0. If it doesn't, and there's pluggage in those nozzles, you might as well shut the air cannon off, because all it's going to do is blast into that material, and eventually that material is going to collect back into the valve itself, and the cannon's going to break down, and it wasn't doing you any good anyway.